Chapter 2. Moving in a New Direction. The people in Grantham, England were excited. A new windmill was being built. In the mid-1600s, windmills were used to turn stone wheels that ground grain into flour. No one watched the windmill's progress with greater interest than the teenage Isaac Newton. Newton noticed how every part of the windmill was put together and how it worked. Then he went home and made the exact model of it, except for one thing. Newton added a tiny treadmill run by a mouse to turn the sails. So when the wind died down, the windmill could still work. Neighbors stopped by to see Isaac's mouse mill playing with motion. The story of the windmill tells a lot about Newton. He loved building models and trying to improve machines, especially if they involved motion. His models weren't just toys. They could do work. For example, Newton built water wheels that were placed in a brook on his family's farm in Woolsthorpe. He also built clocks that worked by dripping water through a small hole. A curious mind. Grade schools in the 17th century England didn't teach most of the things that interested Newton. The subjects taught included reading, writing, Latin, religion, simple arithmetic. But Newton wanted to learn about the world around him. He made a list of more than 40 topics that he wanted to study. They included topics such as motion, matter, time, water, and the sun. Newton had to learn about most of them on his own. The new science. In college, Newton could finally study topics he enjoyed the most. Science and advanced math. But he questioned many things he was learning. Much of the science that was taught in universities at the time had been handed down over centuries from the Greek thinker Aristotle. He had lived 2,000 years before Newton. Aristotle's ideas of how things move seemed wrong to Newton. Aristotle said that a force must keep acting on an object in order to move it. Once the object ran out of force, it stopped moving, according to Aristotle. This and other ideas from Aristotle made some sense, so people believed them, but few people ever bothered to test these ideas with experiments. One scientist who did test the ideas was Galileo Galilei in the late 1500s. Galileo had concluded from his experiments that an object does not need a force to keep moving. It needs a force only to start it moving. Once it's moving, other forces act on it to slow it down. Newton would later expand on this idea in his first law of motion. Galileo and others represented the new science. In college, Newton read the books of these new thinkers who insisted that the ideas be tested. He agreed with the new direction science was taking. Newton began to lead the way. The Miraculous Year. Newton was a university student at Cambridge in 1665 when the deadly bubonic plague broke out. This disease was passed from infected rats to fleas to people. Both rats and fleas were plentiful in the dirty, crowded streets of London. Thousands of people were dying from the plague every week. From London, the plague spread to other cities. By August, it reached Cambridge. The university closed its doors and sent all the students home. Newton packed up his books, notes, pen, and ink and went back to his home in Woolsthorpe. There, with no exams to study for, or plague to worry about, he could concentrate on his work. For the rest of that year, and the next, Newton developed some of the most important ideas in science, including his 3 laws of motion. This time was later called the Miraculous Year. A very important science book. As brilliant as Newton was, he wasn't always eager to share his ideas. Why? For one thing, he didn't take criticism very well. He didn't like anyone challenging his ideas. Also, once he had solved a problem, he set it aside and he moved on to other topics that interested him. That's the way it was with the laws of motion. Almost 20 years went by before Newton told a friend about his laws and other discoveries he made about motion and forces. His friend, scientist Edmund Halley of Halley's Comet fame, convinced Newton to write a book about his discoveries. It was called Mathematical Principles of Natural Philosophy, and this is known as Principia. Many scientists call it the most important science book ever written. Newton's laws of motion help scientists solve other problems. Builders and engineers use the laws to make better structures and machines. Even today, engineers use Newton's laws to design machines that move, from toys to spaceships. I'll give you a minute to glance over the captions there with the telescopes.